Okay, so for the type of questions we're dealing with today, the radical, as we just mentioned, is the square root type of equation. So if we take a look at some simple ones to warm up, you probably don't even need to, maybe you can just guess and check this one. What would you say?
9.
Yay, we're awake. Okay. This one,
4.
sorry?
X equals 4.
Okay, so how did you do that?
4 minus 2 and then...
Oh, you did go that way. Okay, no problem. So let's go this. So you're looking for that number. How do you find that number, root x equals 2? Has anybody got a method? Just guessing? Squaring the square root, yeah. So if we square this, 2 squared was 4. And if we squared 3, 3 squared was 9. So that might help you figure out how we could do this answer here. Well, it's still pretty easy, but yes, 24. Because if I square both sides of this equation, then I end up with x plus 1 equals 25. So x equals 24. And that's the technique that we're going to look at today. Okay, so here's our strategy that we're going to work with. The strategy that we're going to work with has a couple steps to it. We're going to try to isolate the radical as much as possible. Otherwise, it means we're going to have to do some expansion. FOIL, meaning multiplication, it's going to be extra work for us. So we want to try to isolate. And when we do find a solution, we need to check still. The reason we need to check is, for example, if we were to try root x equals negative 3, if I use that method of squaring both sides, then it would tell me x equals 9, which isn't going to work here. So it's still possible, because we went and changed the equation by squaring both sides, there is no solution to this original equation, even though it's trying to tell me x equals 9. We still have to check. Okay, so unfortunately, we still are in that situation of checking our answers. I guess the good news is you can check all your answers. There's no questions we do which don't need it, so just always check. And one thing we also have to remember here is square roots can only have positive values, so be careful that you don't jump out and have something like, negative 3 as your answer, right? We're not going to work with complex numbers, so we'll stick with just the positive square roots. Okay, so if we try the strategy for the first one, if I square both sides, x equals 6. This is a quick one to double check. All I need to do is, I can probably do it in my head. 6 minus 2 is 4, square root of 4 is 2. So yep, that one works. Okay. Here's what I mean by isolating the square root. If we squared both sides, we'd have some problems here, because now when I square it, I'm going to have a mess inside these brackets. When I FOIL this out, there's going to be extra terms. So rather than deal with foiling and having all those extra square roots, it works a lot nicer if we isolate the square root all by itself, like this. That way when I square it, the square roots are all gone in one shot. Okay, so be careful that you do isolate the square root first. It is not the same thing either, by the way, as going x plus 1 plus 9 equals 25. That does not work because FOIL means you have to go root x plus 1 plus 3, root x plus 1 plus 3. So it's going to be this one times that one, and we distribute all the different terms. So there's a lot extra multiplication that happens in there if you don't collect them up and isolate the square root. First, outside, inside, last. So it's the first one in this brackets times the first one. It's just a helpful acronym. It doesn't really matter if you go in that order, but first to first. This is the outside to outside, inside to inside, and then the last terms. It's just to help you remember of doing all 4 multiplications. Okay, so anyways, we can finish that question off quickly then. X would be equal to 3 for this, and we'd want to double check. If I put it in, 3 plus 1 is 4. Square root of 4 is 2. 2 and 3 is 5. So that one works as well. Okay. So the thing that makes these equations a little different from normal is the square root. So that's what we still want to keep by itself. We're not worried about regular x's. We know how to deal with regular x's. Okay, so in this case, this is isolated. It's all by itself. There's only one square root there. There's nothing else attached to it. So when I say isolate, I mean put the square root on one side of the equation and nobody else with it. Okay, so if I square both sides here, that means I'm going to get x minus 4 equals x squared minus 12x plus 36. Okay. And if I collect up the like terms, let's see here. Oh, negative 8 and 5. Good. Oh, negative 5, right. So that gives me an answer of either 8 or 5. So we need to double check that those are actually valid. So if I stick those into the square root of 8 minus 4, is this equal to 8 minus 6? Square root of 4, is that equal to 2? Yes. So I know that 8 is at least one of the answers. Let's go and check the other one, which would be square root of 5 minus 1. 4, thank you. 5 minus 4 equals 5 minus 6. So then I would have square root of 1 equals negative 1. That does not work. So this is not one of my solutions. So I only end up with one answer here, which is x equals 8. Okay, so I'll let you work on the second one on your own. See if you can isolate, square both sides, and solve for this equation. Okay, so if we isolate this one, then this is what I'd like to have. That way when I square both sides, the square roots disappear. And it becomes a kind of equation we've done many times before. So I end up with minus, let's see here, 6 x plus 1. And that gives me x equals 6 or negative 1. And if I go back to the original equation, which is here, let's test those out. Does 6 equal the square root of 6 plus 10 plus 2? Does 6 equal root 16 plus 2? So yes, this one does work. 6 is one of my answers. How about negative 1? If you're clever, you won't even need to check this one. The reason I say that is this is a positive 2. Whatever comes out of the square root must be positive or greater than or equal to 0. So you can never get a negative value out of that combination. Right? You can't add two positives together to get a negative. So you could reject it, but anyways, if for some reason you didn't see that, that's okay. You can still verify it the long way. So that one does not work. Negative 1 is not one of our answers. Can I just see show of hands how many we're doing okay? Excellent. Okay.